Hi, good morning, everyone. Thank you for joining us today. My name is Meta Polywall with the Orange County Water District. On behalf of everyone here at the district, I'm excited to welcome you to our March webinar, Salinity Management, Putting Southern California's Water Supply on a Low Sodium Diet. Before we begin, I'd like to go over just a few housekeeping items. As a webinar attendee, you are muted. This is to reduce background noise. However, should you have a question for our speakers, we really encourage you to type your question into the Q&A box located at the bottom of your screen. And to keep the webinar moving along, speakers will wait until the end of the presentation to answer questions. So feel free to ask questions in the Q&A box as you think of them, and we will address them during the Q&A session at the end. In the event that we run out of time and we don't get to your question, you can always email us at info@ocwd.com, and we'll be happily get in touch with you after the webinar. And lastly, this webinar is being recorded and will be posted to our YouTube channel at OCWD Water News. You will receive a link to the recording via email with the email that you registered with. Without further ado, I'd like to introduce our speakers for today. Warren Tights. Warren is the manager of the resource development team at the Metropolitan Water District of Southern California. Warren and his team manage programs and planning issues for groundwater, stormwater, desalination, salinity management, and other cross-cutting resource issues in Metropolitan's Water Resource Management Group. This includes implementing Metropolitan's Future Supply Actions Funding Program, which funds research to remove development barriers for local water resources. In collaboration with Metropolitan's business outreach team, he is helping to launch Metropolitan's new innovation program. Warren has over 25 years of experience in California's water industry, serving on the boards of the Southern California Salinity Coalition, CalVSAL, and Multi-State Salinity Coalition. He also represents Metropolitan on the National Alliance for Water Innovation. Mark Norton. Mark Norton's background includes 40 years of engineering experience in a broad range of civil engineering projects. He currently serves as the Water Resources and Planning Manager for Sapa, a joint powers authority organized to support water resources in the Santa Ana Watershed. He led the development of the first integrated regional water management program for the Santa Ana River watershed and currently oversees the IRWM plan known as the One Water, One Watershed plan. Mr. Norton also serves as the authority administrator for the Lake Elsinore and San Jacinto Watersheds Authority, a joint powers agency created to enhance water quality for Lake Elsinore and San Jacinto River watersheds. So Greg Woodside. Mr. Woodside has 30 years of experience in water resources management and hydrogeology. He currently oversees the Planning and Watershed Management Department and the Natural Resources Department at the Orange County Water District. Staff in these departments prepare the district's environmental documents and implement the district's natural resource management, integrated regional watershed management, resource agency permitting, and compliance with the Sustainable Groundwater Management Act. Mr. Woodside is also a registered geologist and certified hydrogeologist in California. We're really looking forward to hearing from you all today, so let's get started. Warren, take it away.
Great, thank you, Maida. Good morning, everybody. I hope everyone is well today. I really wish that this would be an in-person meeting, but there is light at the end of the tunnel, and hopefully by the end of the year, we'll be able to have in-person meetings again. It's an honor to be on the same panel with Mark and Greg. And our plan today is to start talking about salinity at the regional level, focus down to the watershed level, and then drill down to the local level at basically Orange County Water District's perspective. My presentation today is going to focus on the Southern California Salinity Coalition, why we were formed, what we do, and what we're doing to help manage salinity in Southern California. Next slide, please. So I'm going to start with just a brief overview of salinity management and salinity in general, give you a little bit more information about the Southern California Salinity Coalition, what are some of the coalition's recent activities, and then I'm going to close with a call to action. So next slide, please. So first, what is salinity? So I'm not a chemist, so many of you know more about this than I do, but it's a measure of salts or minerals that are dissolved in water commonly expressed as total dissolved solids, or TDS. And just to give you some idea of what I'm talking about, here's a graph of the mineral composition of the Colorado River. And I've shaded the sodium chloride, or what we commonly think of salt, in red. These are minerals that are going to commonly cause problems with agriculture. And then the greenish bluish shades are minerals that are going to cause problems typically with scale and household appliances and water heaters and whatnot. So it's a diverse minerals, and this is why we're here today. So can you go to the next slide, please? So there's a problem with salinity. It comes from both natural and human sources. Starting with the picture on the left, drinking water quality and taste. This was brought home dramatically to me during a water taste test at a multi-state Salinity Coalition summit a couple years ago, where we actually tasted waters with different salinity. And the high salinity water definitely had an unpleasant taste. It tasted like sulfur. You look at the shower head on the right, you can see scale buildup. It's not just shower heads, but water heaters and anything touching hot water commercially or residentially is going to have potentially problems with scale with high salinity water. Agriculture crop yields are also affected with high salinity water, as well as turf irrigation. Salinity affects the use of groundwater basins and also affects the use and cost of recycled water for irrigation and for other uses. Before there were, before SGMA, there were, basin plan objectives for groundwater basins and salt nutrient management plans. Next slide, please. So salinity is an ancient problem. Irrigation in Mesopotamia started, thousands of years ago, and the Sumerians developed sophisticated irrigation systems, but they were also challenged by salinity that built up over the centuries of using water from the Euphrates and the Tigris. What I have here is a map of one of the irrigation systems that they developed. There's a main canal that sort of loops in from the top and then loops around from the east to the west. You can see some of the feeder canals, fields in the middle. The circles are cities. This is basically a GIS on a clay tablet. This would be suitable for an urban water management plan. Very sophisticated agriculture there, but they did suffer from salinity, and they came up with management strategies that we still use today: leaching, fallowing, crop substitution. As their fields became too saline for wheat, they switched over to more salt-tolerant barley. So salinity is an ancient problem. It's a problem now, here and today, and it's going to be with us into the foreseeable future. So next slide. So getting back to present-day California, here's a graph of the major imported water supplies that Metropolitan Water District manages, the Colorado River and the State Water Project. And I think there's three takeaways from this graph. The first is Colorado River water is twice as saline as the State Water Project, ranging from about 580 milligrams per liter to 620. State Water Project's roughly half of that. The other takeaway is that the State Water Project varies greatly from year to year. So I don't have a pointer, but if you can try to focus in on 2014, 2015, you can see a spike in salinity. If you look at a couple years later, 2017, you can see a dramatic drop in salinity below 100 milligrams per liter. This is related to water flowing out of the Delta, and I think either Mark or Greg is going to be talking about that in their presentations. The third takeaway is, so on the Colorado River, by comparison, is buffered by storage. And the third takeaway is that the Colorado River has been, you can see a gradual decline, and that is largely due to successful efforts by the Colorado River Salinity Control Forum, collaborating with Metropolitan, other California water agencies, other states, in reducing the salinity of the Colorado River. So next slide, please. So focusing in more on the Colorado River, this watershed was once covered by an inland sleeve, or inland sea, or at least most of it was. And so salt-laden mineral deposits are all over. Public enemy number one is Manco Shale. This is kind of a gray, shaly type of mineral deposit that you can see around there. And it's the salt in that deposit is very soluble. You're looking at the watershed, the water starts out pristine in the headwaters in Colorado River, but as it flows through the tributaries from the upper basin down into the lower basin, it picks up loads of salt along the way. And some of that's coming from natural sources such as highly saline springs that flow into the tributaries, but also partly due to agriculture. So Metropolitan collaborates, as I said, with the Colorado River Salinity Control Forum to manage salinity in the basin. And I would say it's been a success. The forum is controlling over 1.2 million tons of salt from entering the Colorado River every year. And this leads to a reduction in over 110 milligrams per liter of salinity at Metropolitan's intake. Just to give you some idea of the salt that's being carried by the water, about 1 acre foot of Colorado River water contains about 0.8 tons of salt. So roughly about 1 ton of salt per acre foot. By comparison, the water flowing in at Paradox Valley, one of the springs, hypersaline springs I mentioned, is 250 milligrams per liter, 340 tons of salt in 1 acre foot. That's about 4 freight cars of salt that are flowing in with each acre foot. If you look at what the forum is controlling, that's 1.2 million tons of salt every year. That's like 12,000 boxcars of salt that are not entering the Colorado River every year because of these control actions that the forum is implementing. Okay, so next slide, please. One of the reasons why we focus on controlling salt on the Colorado River is because of the economic impacts from those salts. This is a graph that shows what the salinity impacts would be economically if we kept the salinity control levels at 2017 implementation levels, forecasted out to 2035. And you can see lower Colorado River, we'd be up to $500 million a year in damages. Now, more than half of that would be agriculture. As we move to Metropolitan and then Orange County, you can see that the damages switch over to more urban impacts, residential and commercial. Zooming into Orange County, almost 40% of the damages are coming from groundwater and recycled water use, and that's obviously because Orange County has the magnificent Orange County Groundwater Basin and also the Groundwater Replenishment and other recycled water projects. Next slide, please. Thank you. In recognition of that, Metropolitan and the Bureau and other partners got together in 1999 and completed a pivotal study, the Salinity Management Study. And that study was, Bookman Edmondson was a prime consultant. Rich Otwater, who I think is on this call, was a driving force behind this pivotal report. It's a remarkable study, and I think it's still relevant today. It has some major findings and led to some important actions. One of those findings was that the region had a 600,000 ton salt imbalance, meaning more salt was coming into the region than was being removed through wastewater outfalls and natural outflow. Importantly, the study found that about half the salt coming into the region was from local sources. So, we tend to think about the Colorado River State Water Project bringing salt in. Half the salt is from local sources. And it called for establishing the Southern California Salinity Coalition. Also, importantly, Metropolitan, as a result of the study, came up with a blending target of 500 milligrams per liter on an annual average when there was adequate state water project available. So in drought years, we can't meet that target, but in most of the years, we can shoot for that 500 milligrams per liter goal. Next slide, please. So the coalition was founded in 2000 as a result of that study. It's a coalition of water, wastewater, groundwater, and watershed agencies. The current membership, you can see the logos on the right. I'll read the mission statement. The Southern California Salinity Coalition works collaboratively to minimize the adverse effects of salinity on water systems. And the way we do that is through research, advocacy, and outreach. And I think I'm going to spend the next 3 slides talking about each one of those aspects of what the coalition does. Next slide, please. So in terms of research, we try to fund studies that are going to have an impact, are going to inform regulations, are going to help water agencies address salinity. So one study that we completed in 2018 was a study of the long-term salinity trends of rising salinity in wastewater. And Mark is going to talk about this study in more detail. I'll just point out the graph on the lower right shows the salinity of the source water coming in and rising salinity levels flowing into the wastewater treatment plant in Eastern MWD service area. You can see that it's growing over time and that the gap between the source water and the influent is also increasing over time. We're currently funding a study of integrating the Carlsbad Seawater Desalination Project supplies into San Diego's distribution system. This is a follow-up study of a Water Research Foundation study, adding a few more years of integration into that study and seeing how it's benefiting the region. We just funded 2 other studies that are listed here, but in the past, we've also funded studies of softeners, recycled water irrigation guides, and economic impact studies. So moving on to advocacy, we've funded studies to inform the model water efficient landscape ordinance on leaching allowances for recycled water irrigation. We're currently funding a desalination research needs survey that's open now, and I have a link to that embedded in this presentation. And moving on to outreach, next slide, please. We're currently funding, in partnership with KUA, Cal Desal, and other associations, briefing materials on water reuse, promoting the good work that water agencies across California are doing in developing water recycling and water reuse projects, but also discussing the challenges of achieving 100% reduction in discharges to the ocean. So that's something that we're collaborating with, and I think that project's almost done. We hold Salinity Summits. We're planning one for this fall, but the last one we held was in June 2012. You can see a picture of the sort of what that looked like. That was in person in Metropolitan. My colleague Maria Lopez helped make that happen, and you can see some of the luminaries that were part of that summit. In the lower right, you can see a picture of Bill Steele there. He was someone who really believed in salinity management in Southern California, and he's someone who I looked up to quite a bit. We also, the coalition also funds graduate fellowships. And next slide, please. Just a couple words on our graduate fellowships. The application period is open now through April 30th. We fund, each fellowship is $10,000 per year for a 2-year cycle. We're looking for graduate students who are working on any kind of topic that's related to salinity management, brine management, recycled water, and salinity. So quite a broad area. They can be white papers or technical studies, and you can find more on our website about that. And then a link for applications is below, and you can see that we collaborate with the National Water Research Institute on implementing those fellowships. I think that's very important. This is setting up the next generation of water managers and researchers in addressing salinity issues in the region. So next slide, please. So here's the shameless plug for the coalition. Please join us. We're looking to expand our membership, and it's an opportunity to collaborate with peer agencies that have common salinity management issues. We're implementing a multi-year research program to address relevant challenges that we're experiencing right now. It's an opportunity to partner with other associations and other agencies on some of these challenges. And our goal is to communicate compelling information, not just to the public, but also to regulators, legislatures, and other stakeholders and decision makers. Next slide. A couple of ways to engage right now. The first is to complete that desalination research needs survey. I put the link right there. It's open to April 31st, but you can also find it on the Salinity this coalition's website. We're hosting our next meeting in June, and we'll be inviting some targeted agencies to potentially sit in. But if you're interested in finding out more about what we do, please contact me or Kevin Hardy, who's the executive director of the coalition. And again, we're planning a Salinity Summit in the fall of 2021. It's going to be a great program. It probably will be virtual, but look for that, and that'll also be announced on our website and through other forums as well. Next slide. Thank you for your time. My contact information is below. Feel free to contact me at any time. And at this point, I'd like to turn the presentation over to Mark. Mark, go ahead.
Thank you, Warren. Good morning, everyone. It's my pleasure to be with you here today to talk about the Santa Ana River watershed, our brine disposal efforts, and the wonder and mystery of salinity management in inner watershed. Next slide. First, a little bit about the watershed. We're the largest coastal stream system in Southern California, about 2,840 square miles, mostly 3 counties, but we do have a sliver of Los Angeles County, Riverside County, San Bernardino, and Orange County. The northern portion of Orange County cover our watershed. About 60 cities and close to 97 water-related agencies. So we have a lot of fellow stakeholders we work with. Population now is about 6 million people, expecting it to rise to about 9 million people by 2050. Next slide. Here's our member agencies. We're a joint powers authority, Sapa. Our member agencies include Inland Empire Utilities Agency, San Bernardino Valley Municipal Water District, Eastern Municipal Water District, Western Municipal Water District, and Orange County Water District. Next slide. Our primary activities, really, when we first started, it was really focused on salinity management. So our main project that we kicked off was the Inland Empire Brine Line. Back in the early days, used to be called the Santa Ana Regional Interceptor. And I'll be getting into more detail about that. We also served as the facilitator or convener of multi-agency task force efforts we call roundtables. And then the long-term regional water management planning our integrated regional water management plan, which we call One Water, One Watershed. Next slide. As I mentioned, we've been engaged in salinity management for many years, actually closer to 50 years now. We were established in 1972. Obviously, there was a lot of desire to work together between upstream and downstream parties after close to 40 years of litigation over water rights and water quality. With the establishment of our organization, we looked at the most important needs, and one of the most pressing needs was to ensure that our groundwater basins were protected and we can continue to use them, and ensure that this salt that was migrating down through the Santa Ana River to Orange County could be somehow intercepted and collected separately. Next slide. So mystery, what is the mystery of salinity management? Where is the salt coming from? Well, as Warren touched on as well, agricultural practices, fertilizers. We know that dairy manure is very high in salt. And at one time we had the largest concentration of salt in the entire US, right there in Chino Basin. That's changed now. There's a lot of change in land use in the upper watershed. Also, we had large swaths of agricultural lands, irrigation, citrus. That's all largely been developed now. But that legacy of the manure and the salt that came from that and other types of fertilizers is still within our soils. It's migrating down into the groundwater basins and unfortunately contaminating many of the groundwater basins. In addition, we have salt that's being brought in from Colorado River and the State Water Project. So this leads to a huge imbalance of more salt being brought in than salt being taken out. So we had to address this really significant problem facing the watershed. And so Sapa sought to tackle that as one of our main missions when we started off. Next slide. Give you a sense of the scale, and I know Warren touched on a little bit, but for us in this watershed, imagine 37,000 dump trucks lined end to end filled with salt. That is the amount of salt that was being added to our watershed. And so gives you a sort of visualization between LA and Las Vegas, all those dump trucks of salt. It's hard to imagine that much salt being added every year, but that was the challenge that we were facing. Next slide. In addition, we want to use water as many times as we possibly can before we eventually lose it to the ocean. Water recycling is a major focus of our water portfolio. We are leaders in this area, particularly down in Orange County. They have been tremendous in their abilities to recycle water through the Groundwater Replenishment System project down that Orange County Water District and Orange County Sanitation District jointly operates. It's been a tremendous success. Water recycling is also being promoted and supported throughout the upper watershed. And we want to reuse this as many times as we possibly can. But with water recycling, we know that if the salt levels go too high, then they cannot be recycled. So there need to be a solution. Next slide. So the Brine line was constructed. This is a pipeline that's about 93 miles in length, total length. We have various branches spreading across the upper watershed, varies in size from 16 to 84-inch diameter. The pipeline capacity is 30 to 36 million gallons per day. Right now, it's running about half full there. We have a number of direct connections, industrial, desalters, and domestic waste that currently use it. Next slide. As mentioned, about half full. Concentrations right now are ranging between 3,000 to about 5,000, a little bit higher that we show here. That's concentration, though, recognizing is far less than the ocean salt levels. So this is actually comparable to a human tear, the salt levels within a human tear. We remove about 50,000 tons of salt each year. Next slide. Here's a map that shows you the brine line. As you can see there, the various sections, we show various reaches of the brine line as it continues basically from the Huntington Beach treatment plant down in Orange County, extends all the way up, generally paralleling the Santa Ana River into the Chino Basin area, all the way up to San Bernardino. And then we also have a branch that extends up the Temescal Valley all the way up to the connection to Eastern Ennis Water District. Next slide. So what is brine wastewater? Well, oftentimes people, I think, have a sense that that might be something that is brought in or created, but where it really comes from is various activities from industry, from human use. For example, when power companies oftentimes have cooling towers, that concentrates the water that they use, and it cannot be used and sent to a wastewater treatment plant. Also, sometimes there are industrial processes. There are actually software computer chip makers who need really ultra pure water. They have to go through various processes that need to dispose of high saline water, and this has to be disposed of somehow. Even food processing. This is another type of industry that uses the brine line. And of course, all the reverse osmosis desalination groundwater plants that we have throughout the watershed uses this brine line. So how can we safely dispose of it? Next slide. Now, basically, we know that brine can be harmful to freshwater plants and animals. So basically collecting that through a pipeline was really the way to go. We recognized that we needed to do this in order to ensure water recycling, and that the wastewater treatment plants really couldn't accept this water. And the ultimate place there had gone to historically would be the ocean. But before we send it to the ocean, we always treat it. It's sent down to the Orange County Sanitation District's Huntington Beach plant. And the amount of flow is actually a very small percentage of the overall wastewater. It is then goes through the treatment plant there at the Huntington Beach wastewater treatment plant, and then it's disposed of out into the ocean after treatment. Next slide. We have a very keen interest in protecting our watershed. Making sure that we can move these salts out safely helps our natural resources, the surface water as well as the groundwater. that so many people and so many companies are dependent upon. This is our long-term goal to ensure that we have a sustainable groundwater and watershed overall for the future, for future generations. Next slide. As mentioned before, there's a number of industries that benefit, and as you can see, here's a snapshot of a few of them. The power industry. Other ones I may not have mentioned are bottling companies, water treatment companies as well. Water software companies use our brine line, and so it is a valuable asset that oftentimes I think is under the radar, as a lot of our infrastructure is. Many people aren't aware that we have this, and we're doing all we can to make sure that we effectively market this and share it with any developers that might be out there, that we have this pipeline that's available that can be tapped into. Next slide. So what happens to brine is just this sort of graphic shows you from the Inland Empire. That is then sent to the brine line itself, then down to Orange County Sanitation District's treatment plant in Huntington Beach for treatment, and then eventually out into the Pacific Ocean. Next slide. Cost. When we begin to compare the cost of disposal to our brine line compared to other means of doing this, whether it's a truck disposal or trying to truck it out with tankers, the brine line is a good deal. Look at the cost there for non-brine line disposal, and we see these costs compared to, say, out in other regions that don't have a brine line. You're looking at a cost of about 25 cents per gallon, or $250,000 per million gallons. That cost basically drops dramatically under our brine line connection. It is still a challenge, it's still expensive, but nevertheless a lot less expensive than when you compare it to the alternatives. Next slide. A little bit about our salinity management approaches through our roundtables, as I mentioned earlier. Our efforts are really to work with the Regional Water Quality Control Board to ensure that we are looking at collaborative solutions. The task forces that we have, particularly the current Basin Monitoring Program Task Force, looks at trends with TDS and nitrate, and we look at ways in which we can resolve challenges and improve our efficiencies. That relationship we have with the regional board in conducting joint salinity studies and implementation, I think, is a hallmark of success within all the many of the regions across the state. What we have done has been a template for many others as they have embarked upon salt and nutrient management plans. Next slide. Going back a few years, back in '96, for example, we as a group decided that it was time to update the assumptions that were made when they first put together the basin plan back in 1972. So a very detailed and extensive study was done to relook at the water quality objectives for nitrogen and TDS. We did analysis over 1,800 wells and 20 years of data. And some of the successes from that is that we conducted the first maximum benefit demonstration in the state of California for salt management. And this provides some flexibility that exists under the law and compliance with the law. And another part of this, I think it was a real tremendous success, and it continues to this day, is that we have very little objection or dissent when we bring these things to the regional board. A basin plan amendment typically, and if you look at other regions, may be far less successful. And also, I think we largely avoid a lot of the litigation that you'll see in other regions. Oftentimes you look at agendas, and in other regions, there are often laundry lists of litigation cases that they have to deal with. This collaborative roundtables that we have, I think, are a tremendous success in that fashion. Next slide. Basin Monitoring Program Task Force was sort of the next task force after the nitrogen TDS. It was established in 2004. We agreed to the regional board that we would do a update every 3 years to look at the trends within nitrogen TDS, looking at all the groundwater management zones throughout our watershed. We also conduct an annual report for water quality, focusing on nitrogen and TDS. We also do periodically a Santa Ana River waste load allocation. This really basically is a 20-year projection of what the wastewater treatment plants can expect as far as how much they're recycling and how much they will dispose of down into the Santa Ana River. The river itself is actually primarily a effluent dominated river flow. And so we want to make sure that we're continuing to be in compliance with the objectives to protect those groundwater basins throughout the watershed. And a part of that process right now, we've just went through a waste load allocation, and we're going to be bringing that to the regional board as a basin plan amendment. And now our big focus is to look at how we need to modify some of the things that we're doing in light of the 2019 amendment to the recycled water policy the state board recently passed, particularly for the salt and nutrient management plans. Next slide. So another big challenge that we're dealing with, as you all heard about, we are about to enter into another phase of drought. It seems like we just got over one a few years back, and here we are about to enter into another phase of this. It is a significant impact. How does it affect our salt levels? Next slide. Drought can impact water recycling efforts due to less TDS, low TDS water from the state project water. As we know, less flows causes the delta salinity to increase, and that water is eventually transported down, and you'll see those levels rise. Next slide. When that source water is brought to customers and they use it and they add their increment of salt, it's then sent to wastewater treatment plants. And overall, generally, they're able to comply with their discharge permits, but there is always very little margin of error, and it becomes more difficult to meet those requirements under those drought cycles. Next slide. This increases the treatment costs. And if we're not able to comply with those efforts, it becomes really unaffordable. Next slide. The regional board recognizes that TDS levels do change. And so they actually, under their triennial priority list, said, we really may want to look at a drought policy, or looking at how we can look at how we do permits to ensure that we're addressing the multi-year nature of the drought cycles. One of the things that we did, as Warren mentioned, is we conducted a joint study with the Southern California Salinity Coalition, and we've shared those results with the regional board and our stakeholders. Let me tell you a little bit about that study. Next slide. From this study, we learned that indoor water use, under what happens typically under a drought scenario, there's a big emphasis on water use efficiency. And with that, the amount of water that people use drops, but the increment of salt still is maintained there. So there is actually an increase that occurs. You can see these trends that the gallons per capita per day are dropping over time. This is really looking at a snapshot of about 8 years. This is the previous drought period that we went through. Next slide. What that study showed is that over that 8-year drought period, on a per capita basis, the water declined by about 15 gallons per capita per day. But with this resulted in approximately 25 milligrams per liter of TDS increase that demonstrated that there are some impacts from local and statewide conservation. Next slide. So the next steps, based on this study and in talking with our regional board, is to work with the regulators. They have the flexibility actually to look at how the permits are written. And instead of looking at permits and establishing permits based on the monthly average, we had encouraged, and the regional board seems to be amenable to modifying the averaging period to more looking at basically a 10-year rolling average in compliance with these discharge permits, so that we are accounting for these cycles that exist from drought and also the impacts on water use efficiency. So this study has been very instrumental in helping us to leverage the impacts and to encourage a more streamlined permitting process and more effective permitting process as well. Next slide. So overall, the benefits of our regional salinity management for our multiple agencies, it's been a cost-effective compliance approach. We have the regional board staff at our multi-agency task force efforts, Basin Monitoring Program task force staff, and the regional board staff sit together at these meetings. That builds the trust that I think has been invaluable in our region. One Water, One Watershed, we really have been very fortunate in having grant funding that has been brought forth to help offset some of the costs for desalination efforts, help to pay for the Groundwater Replenishment System project, and has really increased that collaboration. It's really so important in integrated planning. And of course, our brine line. It has just been a tremendous piece of infrastructure that has benefited this entire region, this entire watershed, and basically reducing the costs of having to get rid of the salt that is building up in the watershed by having this brine line that we can take it out into the ocean before and then treat it and then out to the ocean for disposal. Next slide. So that concludes my presentation, and be happy to answer questions at the end. And so with that, I'm going to go ahead and turn the time over to Greg Woodside of Orange County Watershed. Thank you.
Thank you, Mark. Good morning, and thank you, Mark and Warren, for your presentations. So the Orange County Water District, we're the groundwater basin manager for the groundwater basin in North and Central Orange County. Next slide, please. This is showing the area that we manage. So we are downstream of Prado Dam, which is an important water resource facility for our area. And we recharge water from several sources, including the Santa Ana River shown here, with surface recharge basins in the cities of Anaheim and Orange. We also infiltrate or recharge recycled water. That water is conveyed from near the coast up through the feature labeled here, our GWRS, Groundwater Replenishment System pipeline. And then we also inject water through our seawater intrusion barrier shown here towards the bottom of the figure. Our recycled water is produced through a joint project with the Orange County Sanitation District, or OC-SAN, and OCWD working together. And then additionally not shown, we have some new injection wells in the middle of the basin in the area of Santa Ana. Next slide, please. So this is a figure that shows the two primary management zones in our area. These are defined in the Regional Board's Basin Plan. So there's a management zone called the Orange County Management Zone, and that's shown in yellow here. And then to the southeast, there's the Irvine Management Zone. Since OCWD's active recharge activities are in the Orange County Management Zone, that's the area I'll be focusing on in the talk this morning. Next slide, please. So this shows our total dissolved solids, or TDS, water quality objective is 580. This is an important reference point when we discuss salinity management, and this again is identified in the Regional Board's Basin Plan. And that number was set to reflect historic water quality from the period 1954 to 1973. Next slide, please. This is a figure that shows average total dissolved solids at production wells in our groundwater basin. So these are wells that have data, and we're averaging from the period from 2015 to 2019. So this gives us an indication of the overall trends in TDS in our basin on an average sense. So you see around the periphery of the basin to the north and east, there's some wells that are over 700, the kind of pinkish or darker blue circles. But then through the middle of the basin is an area where a lot of the TDS is in the range roughly 500 to 600. And then down towards the coast, you see a cluster of wells or an area of wells where there's a lot of that green dots indicating from 350 to 500 milligrams per liter of TDS. Next slide, please. So I want to talk about our water budget. So this is the water that we use to recharge the Orange County Management Zone. Again, just looking at the Orange County Management Zone because that's where our active recharge is. What we're going to do here is we're going to exclude, for this discussion, imported water. Our imported water used for recharge is quite variable. We're not recharging any this year. Other years we'll recharge up to 60 or 70,000 acre feet per year of imported water. But just looking at all of our supplies except imported water, see our biggest percentage of recycled of water is our recycled water, the GWRS Groundwater Replenishment System. So 45% of our supplies would come from that source. And this is a 2025 estimated condition. We currently are expanding our supplies for GWRS water. So we're constructing 30 additional MZD of treatment capacity right now. So this reflects when that's completed. And the other numbers are average conditions for year 2025. So a couple other terms here. See at the bottom, Santa Ana River storm flow, 17%. So this is water we primarily capture through the Corps of Engineers working with us to capture stormwater at Prado Dam. Santa Ana River base flow, also 17%. Subsurface inflow, 15%. This is the water that comes in on the edges of the basin to the north, northeast, and the east, like the Tustin Hills, the Chino Hills. And then portion of water, the 5% at the top there, that this is deep percolation of precipitation and applied water. So this is the small percentage of water that when we water our lawns or have other irrigation activities, it's the water that makes it down to the aquifer. Usually, much less than half of the water actually makes it down that far, but this is accounting for that source. And then 1% Alaminos barrier. Next slide, please. So what this figure shows is the salt in those sources of water. So each of those terms has a different TDS associated with it. And what we see here is that the subsurface inflow is 43% of our salt that comes into our basin through recharge. Next slide, please. So this figure puts these two side by side. So the last two slides put on one slide. So on the left, the volume of the water. So again, 45% of our volume is from GWRS, 17% from Santa Ana River base flow, et cetera. And on the right, you see how much salt comes with each of those sources of water. So the thing that's quite striking here is that the GWRS provides 45% of our water that we recharge, but only 9% of the salt. And that's because the TDS of the GWRS water is so low. Compare that to Santa Ana River base flow that provides 17% of the water in terms of the volume, and then in terms of the salt, Santa Ana River base was 27% of the salt. Next slide, please. So talk a little bit about how this works with our recycled water project. So this is a joint activity of the Orange County Sanitation District, OC-SAN, and OCWD. So OC-SAN provides the primary and secondary treatment. And then most importantly, in this context, they also take our brine back. Next slide, please. In the interest of time, I'm going to skip this one. Go ahead to the next slide. So this shows TDS of 4 different terms here. Just for reference, we have our basin water quality objective. So that's 580. We have an average groundwater quality. This is a statistical calculation that looks at our management zone, the OC management zone, to come up with one number. And that's calculated at 600 milligrams per liter. And then you see the influent to GWRS. So this is our water we receive from OC-SAN, and it has a TDS of 1,000. And then our GWRS product water, after treatment, has a TDS of approximately 50. So where's all that salt go? That salt's removed by reverse osmosis, and then OC-SAN takes that brine back from us, and then it's discharged to the ocean. So we benefit by being a coastal agency with access to an ocean discharge system that OC-SAN operates. That's an enormous benefit for us for salt management. Next slide, please. So I want to look up at some data in our recharge areas. So this is a map that is just in our area of our recharge up in the Anaheim and Orange area. So you see the GWS pipeline along the river that's bringing up our recycled water. And then it shows a series of basins that we recharge our recycled water in that red circle there. So there's 4 basins shown there. Most of the recharge occurs in 2 of those basins. So we're going to look at some of the data to see how the recycled water recharge improves water quality. Next slide. So this is a time series plot of data from 2 wells. So we have a series of wells, 25A and 25, one in the shallow aquifer, one in the principal aquifer. And what this is showing on my screen, the very bottom of the chart is cut off. Sorry about that. But I'll explain the bottom part of the graph too. So what this is showing is chloride concentrations through time. And where you see the first dashed blue line, GWS began in January 2008. That's year 2008, and then time goes to the right by year. So at this well, when GWS began producing water in 2008, we'll look at the red line. That's the deeper monitoring well in the principal aquifer. The chloride concentration was around 100. And then it stayed roughly 100 to the 80 to 90 milligram per liter range. And then the chloride concentration declined 6 years later. So in 2014, the chloride had a noticeable decline. And what we've done is we've mapped and looked at all the wells in the area, and we can see the migration of the recycled water with a decline in the chloride concentration. There's other measures also. You can measure the TDS. You can measure the electrical conductivity. So we can verify with other constituents, but they all show this decline of the chloride concentration, which is an improvement of water quality. And so we identify when the recycled water has reached wells with a 10 to 20% decline of the chloride concentration. So this well is about 2.7 miles downstream of the basin. That translates to, in 6 years, a travel time, a velocity of 2 meters per day. So we can map these, a series of wells, and then draw a contour map of the arrival time of recycled water. Next slide. So this is one of those maps. This is in the shallow aquifer, so roughly wells 200 to 250 feet below ground surface. So what we're mapping here is the travel time in years. And again, this is based on measuring these declines in chloride that's due to the recharge of the groundwater replenishment system water. So this is in the shallow aquifer. So as the water migrates to the west down gradient, it does also migrate vertically downward. And in fact, the deeper aquifer, the next aquifer, set of aquifers down, is where the faster travel occurs. So you'll see this has travel times out to 8 years. This work was done circa 2017. So if we were to update this now, you'd see travel times that would go out to 11 or 12 years. Next slide, please. So you notice here, same type of presentation, but now we're in the principal aquifer, and the water has traveled much further. So you see these travel times, you see a label of 1 year, 2 years, 3 years, all the way out to 8 years. So in 8 years, it's all the way out to just past the 5 freeway. So this is a rapid travel, a rapid flow path to get this kind of distance in just 8 years. It's a improvement of water quality that spreads over this entire area shown here based on the recharge of the recycled water. Next slide, please. So this is a cross section showing the same thing. It's a lot of information here, but essentially a slice through the earth with selected wells shown. So if you go back one slide, please. So this cross section is along that red line through this area. Next slide. So we can identify the travel time in the vertical dimension here. So again, the 1, 2, 3, 4, 5, all the way out to 8, that's the travel time of the GWS water or the recycled water that we identified by looking at the data from all these wells. So you can see here, it's traveled about 200 meters vertically, and laterally it's traveled about 8,000 meters from 2008 to 2016. And again, the reason we're saying 2016 is this analysis was done in year 2017 with data we had through 2016. If we updated this currently to this year, the migration would be even further to the left or to the west. Next slide, please. So this shows a similar presentation of the travel time in our area down here in Fountain Valley and Huntington Beach, where we inject the water to control seawater intrusion. The injection to manage seawater intrusion also replenishes our groundwater basin. So the water that we inject travels down gradient, and so you see these areas that indicate where the recycled water is traveling to. So on the left side of the barrier, the water is traveling mostly to the north, and then in this particular presentation, and then to the east side, the water's traveling towards the east. So we have very variable, highly variable geology down here. So we have different flow paths depending on which aquifer we're in. Next slide, please. So in conclusion, our Orange County Management Zone TDS is improving due to the GWRS water recharge. So when we started GWRS in 2008, we were infiltrating roughly 70,000 acre-feet per year. By 2023, we'll be recharging on the order of 130,000 acre-feet per year of the low TDS GWRS water. So that's improving our sources of supply. And as we improve those sources of supply to recharge, then our overall OC management zone TDS declines. So a declining TDS, that's improving water quality. And our Santa Ana River supplies, since our Santa Ana River supplies are an important part of our recharge to the basin, the TDS of the quality of the Santa Ana River is an important factor for our groundwater basin quality. And with that, I'll conclude and I'll turn it back to you, Meta.
Great. Thank you so much, Greg. And thank you again to Mark and Warren for your presentations. We're now going to dive into the Q&A portion of our program. We do have a few questions that have come through our chat box. And thank you, Warren, for answering some from your earlier presentation, but we'll go ahead and jump right in. And as a reminder, you can go ahead and type your questions into the Q&A box down at the bottom of your screen. And in the event that we do run out of time, we're going to stay on for a few minutes. It's past the 11 o'clock hour, but if you think of a question after our presentation, you can always email us at info@ocwd.com and we'll make sure to get back to you. So question number one, we'll start with Mark. Have the results of Sapa work regarding salinity control that could be applicable to other regional water quality boards and water basin plans been shared with these other regional agencies?
Yes, there's a couple of forums by which we do share. One, of course, is the one that Warren talked about, the Southern California Salinity Coalition. We have multiple agencies there, and we share the results and successes that we experience through our salinity management through that forum. The other is we know that the regional boards, all the regional boards, EOs and support staff do get together on a periodic basis to share their results, learning lessons with other regional boards. So this has occurred, and we are very happy to know and work with our regional board staff. They're just tremendous, and we know that they also do share with others anything that they experience. For example, the maximum benefit demonstration was really a landmark of success, and we were the ones who, and our regional board were the ones who first introduced this concept, and it is within Puerto Colon law to allow that, and we were able to make that demonstration, and now it's being applied in other regions.
Great, thank you, Mark. Next question is, what is causing the rise in chloride concentration after the big dip? I believe that was asked during Greg's presentation.
Yes, I can answer that question. So for the wells that we were showing in our presentation, the chloride declined, and then it had an increase for a period of time. So what's going on there is we shift our recharge of recycled water between different basins, and so the wells I was showing are very close to the flow path, and so if we shift our recharge of our recycled water to different basins, it actually changes what happens down gradient. So it's a reflection of how we shift our recharge of our recycled water among different basins, and that is reflected then downstream. So if we shift a basin that has had the low TDS recycled water and we shift that recycled water to another basin, that's translated downstream. So we'll see variations downstream because of the way we operate our facilities.
Thank you, Greg. And is it possible to get information about the water level and water quality data that you presented?
Yes, we can provide that if you contact us. Yes, our data is publicly available.
Next question. Given the current lack of salt removal in the Paradox Valley, what are the long-term consequences for SoCal TDS? And when will those consequences hit us?
I'll take that question. So you're right, Paradox Valley was knocked out last year due to some seismic activity, and the Bureau has kept it off as they study what's causing that. At the same time, the Bureau has been working towards an EIS for a replacement project. I didn't get a chance to mention it due to time, but that EIS was going to recommend a no action alternative due to the actions of Metropolitan and a number of the Southern California Salinity Coalition and a number of other agencies that are on the call today. We were able to send a letter in and get the Bureau to not issue a no action alternative. And we're going to be looking at a couple of different alternatives to managing the salinity from Paradox Valley. That includes accelerating on-farm and off-farm interventions. So trying to get that same amount of salinity control through managing agricultural contributions, but also there are some private firms that have advanced pond technologies that could be implemented through a public-private partnership. So how long will it take? So the Colorado River is buffered by the storage, and so I've heard that it's going to take about 4 years for that salinity to make it to Metropolitan's intake, somewhere between 2 and 4 years, and that could have I've heard, I think, an 8 milligram per liter increase on average in the supplies that we deliver through the CRA. But thank you for that question.
Thank you, Warren. Is there a plan to divert GWRS water to the Santiago Creek basins in the future?
Yes, we're working on that. That's something that we're currently assessing, and the plumbing is actually pretty straightforward to do that, but we're working through what permit modifications we would need from the regional board and other planning activities, but that is something that we're looking at very carefully right now. So that would be for recharge of GWRS water into what we call the Santiago basins, which are on the east side of Orange.
Great. Thank you, Greg. And one more question for you. Have you been monitoring changes in TDS from the early phases of the mid-basin injection project?
We have. That project is relatively new, so we don't have as much data. I don't have that available to present, but we have a series of monitoring wells around the mid-basin injection wells, and we have been seeing changes in groundwater quality due to the injection. If the person who asked that is interested, we could provide more detail on that.
Great. How do you foresee the implementation of further discharge permitting affecting the use of technologies such as industrial RO?
Guess I'll try to field this one. I'm a little bit less familiar with the permits associated with the industrial RO, but I think with any advanced technologies, there'll be a need for brine disposal. And we do have a compliance plan associated with our brine pipeline that we work with the regional board on to ensure that we're still protecting groundwater resources. And so I think it's just going to continue to show that we are going to have that support of the regional board to encourage that those new industries that need brine disposal take advantage of the brine line and discharge their excess brine flows to the brine line as needed. But overall, for the permitting, as I mentioned before, that was more for the wastewater treatment plants, and I think the longer-term average will certainly be a benefit. It makes sense. It made sense to the staff as well. They had that flexibility. It is actually written into some permits already. Up in the Kaipa Valley Watershed, they have that. But with improved technology, there is going to continue to be a value and need for brine disposal and use of the brine line.
And we did have a question earlier on Paradox Valley. One of this, it's a follow-up. Can you provide an update on Paradox Valley salinity control?
First, let me answer Ramesh's question on whether the fellowship is for graduate or undergraduate. It is for graduate only. And like I said, this is crucially important. If we want to have any chance of lasting as long as the Sumerians did, we really need to get the next generation of water leaders up to speed on salinity. And then I did talk about the Paradox Valley just a second ago. Right now, the Paradox Valley unit is not operating. It was taken out last year due to a series of seismic events. The Bureau was going to bring it back online, but is being very cautious. That last seismic event, the one that they felt in March of 2020, was felt in the local towns, which is disconcerting. And the Bureau and Geologic Survey are investigating that now and if it can be brought online safely. So like I said, there was a replacement project under consideration, or at least the EIS for that was going to be completed. The Bureau was going to issue a no action alternative. We submitted letters, the Coalition, Metropolitan, and a number of other water agencies to have them not issue that no action alternative, which they did. And so now we have the option and time to look for alternatives. That would include, again, addressing irrigation, replacing, basically installing sprinklers and pipelines to reduce the mobilization of salts in the region, and also potentially a public-private partnership with a company that, or companies that have advanced pond technology.
Thank you, Warren. And we'll go with one final question here. And again, we saw a lot of follow-up, and thank you for the responses from our speakers directly to some of these questions. But for all our attendees today, if you think of anything after the presentation or you have follow-up questions for us and our speakers, please don't hesitate to reach out. You can reach out to OCWD and we can share the contact information of our speakers, or some of our speakers did include contact information on their slides. You can reach out to them directly as well. The final question, did you find any impacts of seismic activity on water levels?
Yeah, this is Greg. I haven't seen any data on that recently, but my hunch would be that in our deeper confined zones, if we had transducers to continuously measure water pressure or the water level, that we would see some type of signal from a seismic activity, assuming the seismic event was of a certain size. My hunch would be that we would detect that in our deeper confined aquifers. I'm not aware we have any data on that regard, but I can check with our hydrogeologist and get back to you on that.
Thank you, Greg. Well, thank you so much again, and thank you to all our speakers and attendees for joining us today. We hope you've enjoyed it. We know we had a lot of questions, so again, please keep that conversation going after the webinar as well. We'd be happy to get in touch with you and stay connected. And a friendly reminder that this webinar was recorded and it will be posted to the OCWD website and YouTube page. So with that, thank you very much, everyone, and have a great day.
Thank you.